The next one, actually, it's also very simple. It's mainly as written from the name. Here you can see it's called disable carrier aggregation for VoLTE users. For example, if you already have 4G carrier aggregation being operating, so you still can have VoLTE in the same time. So the VoLTE during the call, you can have a carrier aggregation. So why usually the operator recommend, or in general it's being recommended to disable carrier aggregation? Actually, this is because during the carrier aggregation you can have some impact which might impact your call drop rate, especially for VoLTE. As you know that first all the carrier aggregation in general, it require the ENOD require all the time to deliver the A1, A2, A6 reports which related to the carrier aggregation addition and removal and carrier aggregation cell change, for example, secondary cell change. So for example, those required to be delivered by the ENOD. So if you have more carriers, you require more RRC reconfiguration. So this kind of repetition or repetitive RRC reconfiguration, this is might lead into sometimes into RRC reestablishment if the user is in a poor radio condition, in case if the user didn't receive the RRC configuration message. Also, in general, if you have multiple carrier aggregation, let's assume 2 or 3 carrier aggregation or 4, you require a repetitive SSL configuration, right? Even addition or removal. So this is also can have the same situation where the users during the call trying to add a secondary cell or third cell, or trying to configure some of the carrier aggregation cells, and somehow there is some failures in that. So this increasing the probability that you'll having RSC establishment, which might lead into drop as well. And the third part, in case if you have, as shown here, uplink carrier aggregation being enabled, not only downlink. So in case of uplink carrier aggregation, this is actually will cause a power limitation, because usually the user need to use, for each carrier, it needs to transmit the different power. For example, as I will be highlighting in the next slide, for example, if you have a 23 dB maximum power, so the power need to transmit it between to be split between the two carriers, so the power will reduce by 3 dB. It will be around 20 dB. And assume also you have 3 carriers, it will be go even to 17 dB. So the uplink carrier aggregation in general will limit the uplink coverage, uplink transmitted coverage for the users. So this also can be reflected in the coverage. That's why usually it's being recommended to disable the carrier aggregation during using the VoLTE calls. Let's try to get a figure about this particular area where we have uplink, how it will try to visualize how the power will be split, as mentioned here. So in general, this will be reflected mostly in the VoLTE call drop rate. Okay, as you can see in the figure on the right here, this is assuming that this is the transmission from the U side, and this is the UTX branches. You have two TX branches. The maximum power is 23 dB, and the main idea that you have one carrier for 4G and secondary carrier. So the user now to need to split the power of the 23. So he will send 20 here and 20 here. So this is actually will be reflecting into a less power for this particular users. Even though the max is 23, because the power is being splitted, he lost around 3 dB. And even though if you went for more 3 carriers, this is will reduce even more, and also for 4 carriers will be reduced for more as well. But this is mainly for uplink, and usually even if uplink you have it enabled in the network, usually the maximum supported by the users is 2, and I think usually it's rarely being used in general, but this is just from theoretical background. So this was showing an impact from the one of the networks. For example, you can see there is this simulation for one of the networks. As you can see, there is a good improvement of voltage drop rate after the carrier aggregation was being disabled. And you might not see this in different, like if you implemented in your network, you might see this. This depend on the network situation in general, user location, and many other aspects. For example, how many carrier aggregation you have in the network. But in general, it's being recommended to disable the carrier aggregation for VoLTE users. So let's move to the next feature. Actually, the next feature is, you can say it's exactly, or the next parameter is exactly the same concept as the carrier aggregation. It's for the NSA users. If you have 5G NSA or ENDC, it's also being recommended to disable that. Why? Because the first point again, which we just being highlighted, the power will be split between one leg being transmitted 4G and one leg for 5G NSA. So again, you will lost around 3 dB. So this is limiting your uplink coverage. And this is the main reason actually, because this is limiting your uplink coverage. So in this case, it's not recommended to enable the ENDC for the VoLTE users. So you not required to have this kind of splitting, or in general ENDC being allowed for VoLTE users. You need required to go for this scenario. Also, another scenario that sometimes this kind of ENDC addition, it requires signaling, so there might some interference between the signal interference or race condition, or in other words, the procedures or process of the signaling of the call setup of the VoLTE also being conflicted with ENDC. So maybe in some vendors you will have this kind of conflict that will prioritize, for example, the ENDC addition over the VoLTE. So this might lead into, for example, a call setup issue for the VoLTE. But I think this issue is being usually the vendor address this issue through that pressurizing the voltage signaling over the ENDC. So the main limitation is about losing the doubling coverage. You will lose around 3 dB in case if you are using ENDC for volt users. So it's also being recommended to disable the ENDC for the user in order to improve your drop rate. So this is exactly or similar to the carrier aggregation scenario, which being highlighted in the previous slide.